Over the course of this visual abstract, we will cover the topic of the impact of the temperature and exploitation time on the tensile properties and plane strain fracture toughness in characteristic areas of a welded joint. This research was inspired by damages caused to a pressure vessel reactor after an exploitation period of 40 years, which resulted in the need to repair the reactor by replacing a part of its mantle with newly built-in material. The reactor was designed to work at a temperature of 537 degrees, and for that reason tests were performed on both new and exploited parent metal, weld metal, and heat-affected zone at both room temperature and a working temperature of 540 degrees. Here we can see the chemical composition of the exploited and new parent material, as well as the additional welding materials and their mechanical properties. Tensile tests of butt welded joints at both room and working temperature were performed in accordance with the relevant standards that you can see here. You can also see the geometries of the weld metal and heat affected zone test specimens, as well as those used for the working temperature tests. Here, some of the test results showing the stress elongation diagrams are shown, including the welded joint, the parent material, and weld metal specimens. The impact of exploitation conditions was evaluated by determining the plane strain fracture toughness in accordance once again with the relevant standards. Here, fracture toughness results relative to the temperature are shown for all three welded joint zones. Based on the obtained testing results, it can be seen that the increase of testing temperature also leads to a decrease in the value of critical J integral, and that fracture toughness also decreases. The obtained values of critical crack length AC also has shown a decrease with the increase in temperature. Also, the increase of testing temperature led to the increase of elongation in the specimens. It can be seen that exploitation time significantly affected the resistance to crack propagation, which generally should be related to the weakening of mechanical exploitation properties compared to the new material. In addition, testing results and their analysis have justified the selected repair welding technology used for the replacement of a part of the reactor mantle.